Hello friends, myself R.D. Mahajan presenting my video on indeterminate form, third case 0 into infinity form. Convert that 0 into infinity form either to 0 by 0 form or infinity by infinity form and then apply Cauchy's rule. Uh, Let us see the first example. Evaluate limit of x into log of x as x tends to 0. Therefore, as usual, first step is to find the form. Therefore, as x tends to 0, this x tends to 0 and that log x is equal to log of 0 and log 0 is minus infinity, and therefore limit x zero into infinity form. And as we get 0 into infinity form, either we have to convert it into 0 by 0 form or infinity by infinity. Remember as a rule, whenever the term of log x is there, we keep that log x as it is. Therefore, that limit of x into log of x as x tends to 0, I can rewrite that as limit. I am keeping log x as it is. And then that x I will transfer to denominator as 1 by x so that we get the original term x. Only form I am changing, and limit as x tends to 0, and therefore as x tends to 0, log 0 is minus infinity, 1 by 0 is infinity, therefore form is infinity by infinity. And as we get infinity by infinity form, applying Cauchy's rule. Therefore, it is limit. Differentiating numerator and denominator with respect to x separately, derivative of log of x is 1 by x. Differentiation of 1 by x is minus 1 by x square. Limit as x tends to 0. Therefore, it becomes limit. Transferring this to numerator, it becomes x square divided by x with minus sign, and as x tends to 0, therefore 1x get cancelled, we get limit of x with minus sign as x tends to 0, and as x tends to 0, value becomes 0. That is the answer, or the value of that, true value of that limit. Means original form is 0 into infinity, then I have converted it into infinity by infinity, and as we get infinity by infinity, we have to apply Cauchy's rule, thereby to get the true value of the limit. Here the true value of the limit is 0. Let us solve second example. Evaluate limit of log of x multiplied by tan of x as x tends to 0, and therefore first step is once again to determine the form. As x tends to 0, log 0 is minus infinity, tan of x becomes tan of 0, tan 0 is 0, therefore the form is 0 into infinity. And as we get 0 into infinity form, either we convert to 0 by 0 form or infinity by infinity. Therefore that limit, given limit of log of x multiplied by tan of x as x tends to 0, we rewrite that as, keeping log x as it is, no change, and tan x we transfer to denominator as 1 by tan as x tends to 0, and therefore it is limit as x tends to 0, 1 by tan. Therefore try to get the form, log 0 is minus infinity, 1 by 0 is infinity, therefore the form is infinity by infinity. And as we get infinity by infinity form, applying Cauchy's rule. First of all, I will rewrite that term as log of x find nothing but cot of x as x tends to 0, and then applying Cauchy's rule, it is equals to limit differentiation of log, it is 1 by x, differentiation of cot minus cosec square x as x tends to 0, and therefore it is limit 1 by cosec square is nothing but sine, and therefore it becomes sine square of x, and divided by x as x tends to 0, and as x tends to 0 we get the form sine 0 is 0 divided by x as 0, the form is 0 by 0, and as we get 0 by 0 form, again applying Cauchy's rule. It is limit differentiating that sine square x with respect to x, its derivative is 2 sine of x, chain rule, derivative of sine x is cos of x, and divided by differentiation of x with respect to x, it is 1, and limit as x tends to 0, therefore we get that value as sine 0 is 0 and cos 0 is 1, therefore that term is 0, therefore the value of that limit is 0, or the true value of the limit is 0, which is other than any indeterminate form. One more I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks.